All right, so lastly, section 2.4, which is covering dilations and also compositions. So let's start with the composition part. So number 6, Lacey performs the translation xy to x plus 5, y plus 3, which we know that to be a translation vector, meaning 5 to the right and 3 up to an object in the coordinate plane. Kyle then performs the translation of x minus 4, y plus 2 to the same object after Lacey. So what single translation could have been done to achieve the same effect as Lacey and Kyle's combined translations? And then what term would describe this combination of these two translations? Okay, so basically, Lacey moves an object 5 to the right and 3 up, and then Kyle picks up where she left off and moves that object back 4 and up 2. So we need to determine what would be the best way to just move it once, to translate it once, and we get the same position. Okay, so let me illustrate this. So if we start, I guess let's say we start let's start right here, right? So first, Lacey has to move it 5 to the right. So 1, 2, 3, 4, 5, and then up 3, 1, 2, 3. Okay, so that's where Lacey began at. And then Kyle decides to come over and move it. So he moved it back 1, 2, 3, 4, and then up 1, 2. So this is where we ended at. And so the question is, what one single movement could we have done in order for us to basically have achieved the same thing? Well, if we're looking at this, so from our original point right here, we moved over exactly 1. And we moved up exactly 1, 2, 3, 4, 5. So if I was to do all of this in one movement, my translation vector would be xy goes to x plus 1, comma, y plus 5. And that would be it. That would be my one move that I needed in order to complete this. And lastly, what term describes the combination of these two translations is a composition. A composition is going to be any combination of any kind of rigid transformations like this. All right, so number 9. So we begin with this triangle, triangle ABC, and we're told that this triangle, we need to dilate it using a scale factor of 1 over 4. Okay, so with dilations, this means that we're changing the physical shape of the object. Okay, so in the past, we've talked about translations, reflections, and rotations, and those didn't really change the actual size of the shape. They changed its position. But now we're coming through and we're changing both the size and the position. So when this thing has a scale factor of 1 over 4, what we're going to do, we're going to take that scale factor and we are going to distribute it to the points. Okay, so my original points A, B, and C, these are the points that they are listed at. A is at 0, 4, B is at 4, negative 4, and C is at negative 4, negative 4. So what we need to do is we need to take this 1/4 and we're going to multiply it to the x and y of each of these points. So if I want to determine my a prime, I'm going to take 1/4, multiply it by 0. 1/4 times 0 will be 0. 1/4 times 4 will be 1. So my a prime is going to be at 0, 1. Okay, to find b, 1/4 times 4 is 1. 1/4 times negative 4 is negative 1. So my b prime is at 1, negative 1. To find my c prime, I'm going to take 1/4 multiplied by negative 4, and that's going to be negative 1 and negative 1. So my new triangle, triangle A prime, B prime, C prime, is drawn as such in red. And that's how I use the scale factor. I multiply each number in each point by the scale factor to determine my new points. All right, so for number 12, so we were told to determine first if from object A to object B, whether it was a enlargement or a reduction. And then from there, we need to go through and then solve for X, Y, and Z. So as we see, from A to B, it's pretty clear we're getting smaller. So that's going to be a reduction. Okay, so we know that we're getting smaller. So now we need to determine basically how are we getting small? How much smaller are we getting? Okay, so we know that with a scale factor, we got to be thinking multiplication. Okay, so the only thing that I'm giving here, because I got 3 variables in this new shape, but I am giving this 2. Okay, so if I'm to assume that these sides are corresponding to one another, so the bottom side of A should correspond to the bottom side of B. So I'm going from 6 to 2. So I have to think in terms of multiplication and division. How am I getting from 6 to 2? Okay, so one way you think of is that you are dividing by 3, or you are multiplying by 1/3. So when we're thinking about scale factors, we're thinking about multiplication. So my scale factor for this reduction is going to be 1/3. So now if I want to determine what each of my sides are that I'm missing, my x, my y, and my z, I need to take the corresponding parts and multiply them by 1/3. So if I want to find x, I need to take the left side here, which has a length of 3, and multiply y 1/3. So that tells me that x should be 1. Okay, y corresponds with this top side. So 6 times 1/3 will be 2. So y will be 2. Z lines up with the right side. So I'm going to take 3, multiply by 1/3. So z will be 1.